Hi everyone. In today's video, we're going to be going over an IEB final paper. It's from November 2022. It's the final paper for mathematics, paper 1. Let's get into it. Firstly, I just want to highlight two important instructions on the instruction sheet. The first one is this: make sure your calculator is in degree mode. So very important, we got to make sure the calculator is in degree mode. So let's just double check and let me show you how that would look. So if you look at the calculator over here, you see how it's got this D symbol over here. Okay. If it's not in the D symbol, what you can do is you can go Shift, Setup, and make sure over here, you press 3 for degree. So you got to make sure it's got that D symbol over there. Okay, good. Let's close that. Second important instruction I want to show you is this one. So make sure you know how many decimal places you need to round off to. In this case, we're rounding off to 1 decimal place, unless they specify otherwise. One important detail you'll see will come up later is in the finance section. When we're dealing with money, they want us to round off to 2 decimal places. So we wouldn't put it at 1 decimal place because you don't say, I have 1 rand, 5 cents, right? You have 1 rand 50. So it's always to 2 decimal places, money. Okay, but otherwise 1 decimal place. Cool, let's get into it. Question 1 is we're solving for x, and we need to leave our answers correct to 1 decimal place if necessary. So just like the instructions on the front. In this first example, it's pretty basic. We just got to make sure we're foiling over here. So we're just going to foil it like that. We're going to get 12x minus 3x squared minus 4 plus x is equal to 0. So we get minus 3x squared plus 13x minus 4 is equal to 0. All right. So what we can do here is we can just use our calculator, and it makes it a lot easier. So I'm not sure if you guys know this, but I'm going to show you guys. What we can do is we can go to mode and we can press 5. So 5 is the equation mode. So if we look at 5, you'll see option number 3 is for quadratic. That's the basic form we have to get our quadratic in to apply the quadratic formula. So it's ax squared plus bx plus c is equal to 0. So a is the coefficient of our x squared, b is the coefficient of x, and c is our constant. So you can see on the left here, our quadratic is in the right form. It's ax squared plus bx minus our constant, plus our constant is equal to 0. So the important part is we got it equal to 0. So if we press 3 over here, it's going to take us in. So a is the number, or the coefficient of x squared, which is negative 3. B is the coefficient of x, which is 13, and c is our constant. In this case, our constant is negative 4. So careful, not plus 4, negative. We press equals, and we press equals again, we'll find that our first x value is equal to 4. So I can write here x is equal to 4, or x is equal to, I go back to my calculator, I press equals again, and I'll get my second option, or x is equal to 1 over 3. Okay. X is equal to 1 over 3. So those are our two options. Okay. In the next example over here, we have this question. So you'll see our x is in the power position. So it's in a position of power. Okay, so it's in the power position. When we have a variable in the power position, we need to do the inverse of our base. So the inverse of exponential is logs. We use logs. So here what we need to do is we need to do log 2 of both sides. So if we do log 2 on the left, log 2 and base 2 cancel. So we're left with 3x. And on the right, we have to actually do log 2 of 7. Okay, because exponentials, so 2 to the power of something, the opposite inverse operation of that is log 2. We take the log 2 of both sides. So if we do that, I'm not going to round or put this thing on the right in my calculator just yet, because I don't want to round too early. So what I'm going to do is I'm going to write this divided by 3. And what I'm going to do now is I'm going to put this in my calculator. And when I put it in my calculator, I'll find that it's 0.9. Careful, make sure it's to 1 decimal place. Good. Again, in this next question, we're solving for x, and we're leaving our answer to 1 decimal place if necessary. So we need to be a bit careful here. So we're dealing with an inequality. So it's no longer an equal sign, it's an inequality sign. And we're going to be dealing with x squared. So we need to be careful when we're dealing with an inequality that has x squared. Let me show you. So we're just going to distribute this x over here and here. We're going to get x squared minus x is less than 20. So we bring over that 20 and we get this, less than 0. So now we could use a calculator, but like before, or what we can do is we can just factorize this. It should be a plus, less than 0. Okay, now before we would just say x is equal to 5 or x is equal to -4, but because it's an inequality, we need to be a bit more careful. So what we actually need to do here is identify our critical values, or CVs. So our first one is 5, and our second one is -4. So what we do now is we draw a number line like this. Okay, so -4 goes here on our number line and 5 goes there. So what we have to do now is we need to determine the sign of this thing. We need to determine the sign. So what we do is we plug a number to the right of 5 in over here where I put the arrow. So something like 10. If we put a 10 in place of this x, you'll see that we'll get this will be 5 and this will be 14. So you'll see this will be positive. Okay. And if we put something like x is equal to 0 in here, you'll see we actually get a negative. And if we put something like a -6 up there, we'll get a positive number. Okay, so this is our number line. And we need to solve for when this is less than 0. So you see we're less than 0 between -4 and 5. And just one thing, we know that we're 0 at these points. Okay, but they're asking for when we're less than 0. So we can't actually include -4 or 5. So that's why we write this symbol, but not equal to. So x is bigger than -4 and x is less than 5. That's how we write it in inequality form. In the next question, we have to determine the values of p for which the roots of that thing over there are real and equal. So whenever we're talking about roots being real and equal, we need to be thinking of delta. So delta is equal to b squared minus 4ac. Some people, you can also call it the discriminant. So when the discriminant is real and equal. So when you would know from your theory, from the nature of roots, that when roots are real and equal, that means our delta is equal to 0. Okay. So the first step though is what we need to get this in its standard form. So what I'm going to do is I'm going to multiply it out just like this. It's equal to 2p. And again, it's not in standard form until we have equals to 0. Now we're in standard form. Okay. So we need to plug in, we need to determine our discriminant. So let me write the formula here again. And b, like we did before, is just the coefficient of x. A is the coefficient of x squared, and c is our constant, this whole thing. So if we do that, we get b squared, which is minus 6 squared, minus 4a is 1, and c is negative 2p. Just be careful with your signs there. So it's this entire constant. So it's not just the negative 2, it's this entire thing. Okay, is equal to 0. If we simplify this a bit more, we're going to get plus 8p is equal to 0. And what we'll find is 8p, excuse me, my voice, is equal to negative 36. So p is equal to negative 36 over 8, which is equal to negative 4,5. In the next question, we have to solve for x if x plus 3 all to the power of 1 over 3 is equal to negative 2. So we have this. To the power of 1 over 3 is equal to negative 2. So we need to get this x out of here because we need to solve for x. And we don't like this 1 over 3. So what we do is we try to cancel it, okay? And the way we cancel it is by timesing by the inverse of this thing. So we have 1 over 3. So what we're going to do is we're going to times it by 3 over 1. And what we do on the left, we have to do on the right. So when we do that, these are going to times to give us 1. So it's going to be x plus 3 to the power of 1. Let's keep it like that. And on the right, we're going to get negative 8. So we don't actually have to have that bracket. So I'm just going to remove it. And if I solve for x, I get negative 11. Now for this next question, I keep saying that, but in this next question, we have to solve for x if log base 3 of x plus 5 minus log 3 of x is equal to 1. So log base 3 of x, sorry. One thing I found interesting is, if you look up here, this is a question we're just trying to solve, and this is from November 2022. But this question here below, although it's slightly different, instead of a plus, there's a minus there. But this is a very similar question. There's even the 1 here. And you solve it in a very similar way, almost exactly the same way as you need to do in this question. So the question here at the bottom was from November 2021, and this question over here was the paper just after that in November 2022. So I just thought it was interesting. They don't often repeat questions like this, but again, I just thought it was interesting and thought it's one of the reasons why past papers are super helpful. So now that that's out of the way, let's look at this. So this might look a bit intimidating, but we just need to use a few of our log laws over here. So one of our log laws say, we should know this from theory, is that if we have log of A minus log of B. So I just want to point out, if you don't see, you remember that if you don't see something, a base here, it just means log 10. But this could be anything. This could be log 3 in our case. Okay, so let me just write log 3, but this could be anything. It could be anything. All right, so that's equivalent to log 3 of A divided by B. So let's use this fact on the right to solve for what we have on the left. So what I can do is I can write log 3. I write, this is my A, and over here, this is my B that I need to divide by. And nothing's changed on the right, so I write equals to 1. So like we did before, when we have this, this base log 3, what we have to do is now we have to introduce a base 3. So if we put a base 3 on this side, the log 3 and base 3 will cancel. So this is what we're left with. Let me just fix this. So this is what we're left with on the left, but now we have to put everything to the base of 3. So we have a base 3, this was our number 1, so it now goes in the power, because we have to undo this log base 3 by putting a base 3. So if we solve for this, I just multiply by my LCD, that's x, and I get this. So I have 5 is equal to 2x, so x is equal to 5 over 2, which is just 2, 5. Good. Then for our next question, we have if w is equal to the square root of 7 minus x, then for what values of x is w non-real? So this is important here, this non-real part. So when something is non-real, that means, if we do non-real, that means we're taking the square root of a negative number. We're taking the square root of a negative number. So that's what non-real means, square root of a negative. So for w to be non-real, we have to be taking the square root of a negative. So this 7 minus x has to be negative. So 7 minus x has to be negative. In that case, we will have w will be non-real, and we're solving for the values of x. So if I rewrite this, 7 is less than x. So when x is bigger than 7, then w will be non-real. Okay. So you could also write it like this, where x is bigger than 7. This way over here is more often how we write it than at the top. Okay. But it shouldn't matter too much. Then they say solve for x if w plus 2 is equal to x plus 1. So what I've done here is I've just put our w here at the top right. And we just need to substitute in this on the right when we see w. So we'll have that 7 minus x, I wrote this a bit big, but anyways, plus 2. So careful, that 2 is on the outside. So don't be tempted to put that 2 there. It's outside the square root. Okay. So you do x plus 1. So very important, whenever you get the surd and x is in the surd, what you have to do is you need to get everything to the other side. So this 2 has to go to the other side because we need this thing in the block by itself. Very important. So 7 minus x, square root, equal to x minus 1. All right. So to undo the square root, we have to square both sides. We have to square the left, and if we square the left, we have to square the right. But we have to put a bracket around everything on the right, because we square the left and the entirety of the right. We can't just put a square here and a square there. That won't work. We have to square the entirety of the right. So on the left, what we'll be left with is 7 minus x, because the square will cancel the square root. And on the right, what we'll get is, we just need to write this bracket twice. That's what square means, okay? So we get 7 minus x is equal to, I'm just going to do this quickly here for us, plus 1. Okay, so we get that, and then we just need to get this in our standard form is equal to x squared. Let me just fix this again. X squared minus 2x. Right, let me go back. What we're going to do is we're going to have 7 is equal to x squared. This stays minus x plus 1. So next step, we get x squared minus x minus 6 is equal to 0. And here we have x minus 3, x plus 2 is equal to 0. So now what we have to do is we're not done. We need to be very careful. We need to go back and check. So firstly, before we check, we need to write our two possible solutions. X is equal to 3 or x is equal to negative 2. So we're not done because we were dealing with the square root, right? We have to go back and check our answers. Okay, so the way we check our answers, you don't have to write what I'm about to put here on the left. Sorry, you don't have to write what I'm about to write here on the right. So everything I'm writing from now on, you don't actually have to show. You just need to check this yourself. So what we need to do is we need to substitute our x's into our original line over here. So this line over here. And we need to check, is it true? Is it valid? All right. So we check the left-hand side by substituting in our x is equal to 3. So if we do that, we're going to get 7 minus 3, the square root of that, plus 2. That gives us square root of 4 plus 2, which is 4. And we check the right-hand side. So the right-hand side will just be 3 plus 1 is equal to 4. So you see our left-hand side and our right-hand side are equal. So we're all good there. So that means that this was valid. Okay? You don't have to put that tick there. Then what we need to do is this was for x is equal to 3. Then for x is equal to minus 2, we check the left-hand side. So the left-hand side is 7 minus, careful now, minus x, and our x is negative 2, plus 2. So if we evaluate that, that's going to be the square root of 9 plus 2, which is equal to 5. And our right-hand side, what we have is, we're going to have minus 2 plus 1, which is equal to minus 1. So you see how our left-hand side and our right-hand side are not equal. So this is not a valid answer. So we cross it out like this. Actually, it doesn't matter too much, but we normally cross it out right to left. In this question, we have to use first principles to find g prime of x if gx is negative 3x squared. So I like to do two steps. First step is I like to check this. Okay, so what we do is we use our normal rules of differentiation, where we have to take this power, take it forward, and then decrease it by 1. So we're going to do that, and we're going to get negative 6x. So what this is, this forms our goal. So we know at the end, if we've done our first principles correct, this is what we need to be ending up with. And the second thing I like to do is I like to work out what my g x plus h is. So one thing I want to point out is here they're talking about f prime. So it's not an issue. You can just replace this f with a g. So this f as well with the g and that one. So don't let that bother you. So what I have to do here is whenever I see an x over here in gx, I need to replace it with x plus h. So what ends up happening is I get this. So instead of x squared, I get x plus h squared. So if I multiply this out, so you can write the bracket twice and use your normal rules. I'm just using the short way over here. And that gives us 3x squared minus 6xh minus 3h squared. So now I can write the actual formula, first principle formula. The limit as h tends to 0 of gx plus h minus g of x over h. So when we do that, we just substitute. So firstly, let me just talk about this limit thing. I know it's annoying, but you have to keep writing this limit as h tends to 0 until this is h is gone, and then you've substituted h is equal to 0. So it has to keep being there. So you have to be careful and just take note of it. It needs to, you have to keep writing it. I know it's annoying, but it's important. Okay. So we keep writing this thing, and we get g of x plus h, which is just this thing over here. So we write that. And we minus g of x. So be very careful here. G of x is negative 3x squared, and we have to minus that. Okay. And all of that is over h. So if we continue over here, we're going to get that the limit as h tends to 0 of minus 3x squared minus 6xh minus 3h, I forgot the square, 3h squared, sorry about that, plus 3x squared. This is all over h. Okay, if we rock with this, you'll see that these cancel. So we're left with the limit as h tends to 0 of negative 6xh minus 3h squared all over h. So what you'll notice here is we can actually take out a common factor h, and we have to do that because we have to get rid of this h at the bottom. So we still write the limit as h tends to 0, but now what we do is we take a common factor of h, that's 3h, all over h. So what you see now is these will cancel. This h and that h at the bottom will cancel. But because we haven't substituted h is equal to 0 yet, we have to still write this limit thing. So you'll see we have to write the limit thing, and this is what we're left with. But you'll see is here we can substitute h as 0. We can just put a 0 over here. Okay? And when we substitute in that h is 0, then we don't have to write the limit anymore. So the limit falls away. And you'll see that this is our final answer. We just got to double check if it equals our goal up there. And because it does, means we did the right thing. Nice. In this next question, we have to determine f prime of x if fx is given by this on the right. So we don't have to use first principles because I haven't explicitly said by using first principles. So please don't use first principles here. So the first step is we have to rewrite our f of x to make it a bit more workable. So that x, we can write it at the top to the power of minus 1. And we can use our exponent laws to write this as x to the power of 5 over 3. So now that it's in a more workable form, we use our rules of differentiation. So what we do is we take the power of x, this thing, and we put it in the front Okay, so we multiply it with this thing, and we keep our coefficient. And then what we do is we decrease the power by 1. So we say minus 1, minus 1. So that's plus 5 over 3 to the power of x, 5 over 3 minus 1. So when we do that, we get minus 5 over 3, x to the minus 2, plus 5 over 3, x to the power of 2 over 3. Good, not too bad once you know the rules of differentiation, I hope. In this question, we're given this parabola, and they say that A over here is a y-intercept, and B is the x-intercept of f. And they want us to calculate the coordinates of A and B. So pretty simple. We're given the equation of the parabola, and we need to find A and B coordinates. So A is just a y-intercept of a parabola. So that's just if we set x is equal to 0. So we write y is equal to 0 squared minus 2 times 0 minus 3. So that's just equal to minus 3. So we know the coordinates of A is 0, minus 3. We can also write it here. Good. And then for B, B is just the x-intercept of our quadratic function, our parabola. So we know that y is equal to 0 at our x-intercepts. So we just write this. And we factorize this. Again, you could use your calculator, but it's simple enough to factorize. So we get x is equal to 3, or x is equal to minus 1. So we have two possible options, and you need to be careful because this one has to be minus 1 because it's on the side of the negative x-axis. So this one has to be the 3. So this is 3, 0. So the coordinates of B, we have to write here, are 3, 0. Nice. Now it says determine the coordinates on the point of f, so on our parabola, where the tangent to f is parallel to line AB. So firstly, we need to look here. Parallel. So when we think of parallel lines, we need to be thinking of where the gradients are equal. That's when lines are parallel. So we need to find the coordinates on the point of f where the tangent is parallel to the line AB. So we know how to find the gradient of the tangent, that's just the derivative at that point, and we know how to find the gradient of AB because we know the coordinates. So we know that A is the point. I just want to double check. Yeah, okay. I was making sure that I put this as 0 and negative 3. Good. And then B is the point 3, 0. Just confirming if it agrees to what I put there. Good. So I can work out the gradient of AB. I just use this formula. It is on your formula sheet. And y2, I'm going to put 0 minus negative 3 over 3 minus 0. So when I do that, I get 3 over 3, which is 1. So I know then that the gradient of the tangent has to be 1 as well. So I can say, therefore, the gradient of the tangent is equal to 1. But how do I find the gradient of the tangent? I know that f prime of x will give me the gradient of the tangent at some unknown x. And I know that's equal to 1, again, at some known x. So I need to go back and find my f of x. So my f of x is given by this. I'm going to write it here for us. I know f of x is equal to, what was it? X squared minus 2x minus 3. So that's my fx. So I know my f prime of x, using my differentiation rules, is this. And I know this is equal to 1 at some unknown x that I'm trying to find. So if I solve for this, I'm going to get 3. So x is equal to 3 over 2. So now that I have that, they're asking for the coordinates. So I only have the x part of the coordinates. So 3 over 2 is somewhere here, about halfway. So I have the x part, I just need to find the y part. So all I need to do is I just put this back into this equation over here to find my y. So when I do that, I get 3 over 2 squared minus 2, 3 over 2 minus 3. And if I put that all in my calculator, I get negative 15 over 4. Cool. Next question. So we're given an arithmetic sequence, and it's given by this general formula over here. So it says determine the number of terms in the sequence if the last term is 198. So the number of terms in a sequence is just given by n, and we know what the last term in the sequence is. It's 198. So we know the last term is 198, so we just need to solve for this. 198 is equal to 5n minus 2. So we'll have that 5n is equal to 200. So n is equal to 40. So that's the number of terms in this sequence. Then they say determine the sum of all the terms in the sequence. So for an arithmetic sequence, you get this formula in the top right on your formula sheet. So I've just given it here for reference. Okay. So we know n is the number of terms. A, we don't know, but we can find. A is just the first term in the sequence. And d is our common difference, which is just this coefficient of n. So this is d. To find a, so a is equal to the first term. And that's just equal to, we use this formula over here, 5 times 1 minus 2, which is 3. So we know a is equal to 3. So if we sum the first 40 terms, so because we're summing the first 40 terms, we can just say s of 40, because we know our n is 40. So we put this over here and we say 2 times 3 plus n minus 1, which is 40 minus 1, times d, which is 5. So I just want to point out one thing here. You see, d is just touching this bracket, but here I've wrote times 5. Because if you just put d touching the bracket, if you just put 5 touching this bracket in your calculator, you'll get a syntax error. So you have to put this times 5 to avoid that syntax error. So if we put this in our calculator and we evaluate it, we'll get 4020. So that's the sum of all the terms of the sequence. All right. In the next question, it says the sum of the first n terms of a geometric series is given by this formula over here. So this is an important formula. So this is the sum. So it's not the term number, it's the sum of all the terms. And it says determine the 9th term in this series. So the 9th term is actually T9. So we need to find T9, but they're given us this formula for the sum of n terms. So I want to point out something interesting. If I give you this geometric series over here, so you'll see here r is equal to 2. So if I find the sum of the first 4 terms, sorry, this is an s, the sum of the first 4 terms, that's just 1 plus 4, sorry, I've missed the 2. The 2 is meant to be there. So it's 1 plus 2 plus 4 plus 8. So if I do that in my calculator, I will get 15. And the sum of the first 3 terms is equal to 1 plus 2 plus 4, which is equal to 7. But I want you to notice something interesting here. If I take the sum of the first 4 terms and then take the sum of the first 3 terms and I minus them, I'm going to get 15 minus 7, which is 8. So if I take the difference of the sum of the 4 terms, the sum of the first 3 terms, I'll actually just get T4, because 8 is T4. You'll see over here, this is T4. So that's essentially what we're going to be doing to solve this problem over here. So this was just an introduction to this question. You didn't actually have to show what we did here. This is just to explain the process. All right. So if we do the sum of the first 9 terms, I don't know why that is a Q. First 9 terms, we're going to get 8 minus 2 to the 3 minus 9. If we put that in our calculator, we're going to get 763 over 64. Then the sum of the first 8 terms is going to be 8 minus 2 to the 3 minus 8, which is equal to 731 over 32. So you could obviously just leave these as improper fractions, you don't have to write them as mixed. It was easier for me to look at the memo and they wrote it as mixed. So we know that then T9 is equal to the sum of the first 9 terms minus the sum of the first 8 terms. So we take these two numbers and we subtract them. And when we do that, we get 1 over 64. So that's how we find T9, the 9th term. In question 5, we're given a cubic function, g of x is equal to x cubed minus 3x. And we're given that a and b are turning points of g. So they're turning points. And COD, COD, are the 3 intercepts, x-intercepts of g. So that was just our information. It says determine the coordinates of a and b. So we remember that the gradient of a function is equal to 0. So the gradient of the tangent is equal to 0 at turning points. So we know that at a and b, we know that g prime of x is equal to 0 at these points. So first step is we find g prime of x, equal to 3x squared minus 3. And we need to solve where this is equal to 0. So when we do that, we get this. And then when you solve that, we'll get plus or minus 1. So this square is not meant to be there. Sorry. Let me do it properly, actually. X squared, 3x squared is equal to 3. So that means x squared is equal to 1. So x is equal to plus or minus 1. All right. So we know that the value over here is minus 1, the x value. And we know the x value here is not x, it is 1. Good. But they ask for the coordinates of a and b. So we know that the x coordinate over here is minus 1. So what we can do is we just substitute minus 1, this minus 1, into here to find the y value. Because remember, this is just y. So y is equal to, let me start with negative 1 minus 3 to the power minus 1. So if I evaluate that, I'm going to be getting 2. So I know the coordinates of a is minus 1, 2. And very similar, I just do the same thing, but now x is equal to 1. And I put this into g. And when I do that, I get that my y is negative 2. So I know the coordinates of b is 1, negative 2. Now what we have to do is we have to sketch g prime of x. So if you remember, g prime of x is equal to 3x squared minus 3. That's our g prime of x. So to sketch a function, we have to know the x-intercepts and y-intercepts. So let's find that. To find the x-intercept, we set y is equal to 0. So we get this. And from before, we know that the solution for this is plus or minus 1. So those are our x-intercepts. So we know we're going to have an x-intercept there and there at minus 1 and 1. Then to find our y-intercept, we set x is equal to 0. So we get this. And we find that our y-intercept is negative 3. Okay, so if you remember, this was a coordinate 1 minus 2 from our previous question over here, down here at the bottom. So let's remember that. So here's negative 2. So we know this is negative 2. So approximately about here will be minus 3. Y is equal to minus 3. And we know that we're plotting a parabola, and we know that the parabola looks something like this. Okay, so we know a parabola will look something like this. Whoopsie. Sorry, my drawing's not the best. Okay, so this is the graph of G prime. All right, so make sure we label these points. We label them properly. Okay, good. Now what we have to do is we have to determine the equation of the tangent to the original function g of x at x is equal to 3. So to determine the equation of the tangent, we need two things. We need the derivative of g of x, so we can find the gradient of the tangent. So we need the gradient of the tangent and we need a point. So with that point, we need a coordinate, x and y. So let's start off with the gradient. So we're going to have to evaluate g prime of x because that gives us the gradient of the tangent. So if you remember, g prime of x is 3x squared minus 3. But we need to find g prime of x at x is equal to 3. So we just substitute 3 in here for x. So when we do that, we're going to get that our gradient is equal to 24. So now that we've got that, we need to find our point. So we have the x value, but we need to find the y. To find the y value, remember this is just y. So here we just need to be substituting in a 3 for our x to get this point. So we can just say g of 3 is equal to, so that's going to be 3 cubed minus 3 times 3. And we do that, we're going to get the point 18. So the point is 318 that we're going to substitute in. So the equation of our tangent is given by this. So we know m, this is m. So we have y is equal to 24x plus c. So now to find c, we do the step 2 where we substitute in this point. We get 18 is equal to 24 times 3 plus c. And when I evaluate that, I'm going to get c is equal to negative 54. So we're not done because they asked for the equation of the tangent. So you need to write it in its proper form with all the unknowns filled in. So this is how we would write it. This is the equation of the tangent as our final answer. Cool. Now we start off with some finance. So we start a business and we buy a delivery truck for 450,000 Rand. So this is the principal amount. If the inflation rate, so inflation is 6% per annum, how much will a new delivery truck cost in 5 years' time? 5 years. So inflation, whenever you see inflation, we're working with compound interest. So inflation is compound. So here it's just a simple little compound interest formula. So this is given on your formula sheet. So when we do that, our principal amount is 450,000. 1 plus our interest rate is 6% per annum. And our periods, number of time is 5 years. So if we put this in our calculator, we should be getting 602, 201,51 Rand. So very important to remember the Rand symbol. And remember, as I said earlier, when we were working with finance, 2 decimal places, money to 2 decimal places. I know the instruction sheet says 1, but finance, we do 2. Okay. Then for part B, we're doing depreciation, and that's at 20% per annum, and we're using the reducing balance method. What will the value of your delivery truck be in 5 years' time? So again, the reducing balance depreciation method is given by this formula. So do you see how it's this almost the exact same as compound interest, but just with a minus? Okay, and again, this is on your formula sheet. So our principal amount is still the same because we're working with the value of our truck. 1 minus 20%, 0.2 as a decimal, power of 5. And when we evaluate this, we get 147,456 Rand. Okay, remember the Rand symbol. So that's how much our truck will cost after 5 years' time that we bought for 450,000. So this is because of just as cars get older, their value decreases for a number of reasons, like wear and tear, and it's just not a new model anymore. But this is how much, that's for part B. For part A, the 602,000, that's how much a new truck will cost. That originally cost 450,000 because of inflation. So because of the increase of the price of goods every year, the new truck will cost that much, 602,000 in 5 years' time. So we need to use those two values in this part C over here. So we set up a sinking fund, okay, and it's for the next 5 years. So we're going to trade in our delivery truck and buy a new one by financing the difference with the sinking fund. So we know how much the old truck cost that we're going to trade in is this 147,000. And we know how much the new one costs, 602,000. So you see how if we just give them our old truck, we still got to cover that difference, which is, what is that? It's going to be about 450,000 roughly. So that's the difference that we're going to have to sort out with our sinking fund. So the bank offers an interest rate of 9% per annum compounded monthly. So we're going to have to be careful with this compounded monthly thing now. So how much should you put away at the end of each month? Okay, because remember, a sinking fund is when you keep contributing money into it so that you have enough to finance the difference between the new vehicle and trade-in value of your delivery truck at the end of 5 years. The last payment is made into the sinking fund. It's made at the end of the 5 years. Okay, so the first step is we need to calculate how much money is the difference of how much money we're going to have at the end of these 5 years to cover the difference. So what we do is we take our answer from part A. So this is the cost of a new truck from part A due to inflation. And what we have to do is we need to subtract the value of our trade-in, because this difference will tell us how much money we're going to have after these 5 years to cover this difference. And this, like I said before, was about 450,000. It actually comes to this value over here. Okay. So this is the difference. So this is how much we're going to have at the end of these 5 years to cover this. So when we do sinking funds, we use the future value formula. So I'm going to write the future value formula up here for our convenience. So it's x 1 plus r, sorry, 1 plus I, that should be an I, 1 plus I to the power of n minus 1 over I. Okay, so this is the normal future value formula that we're going to have to use, because this is what we use for sinking funds. So for a sinking fund. Okay, so we know how much we have to cover. So if we look at the formula, we know what the future value is, because this is our future value, because this is how much we're going to have in the sinking fund after 5 years to cover for the difference. We don't know what our monthly payments is, because they're asking us here. Where did they say? How much should you put away over here? How much should you put away at the end of each month? So what we don't know is this x. We need to solve for the x. We know the interest rate and we know the number of periods. We need to be a bit careful with the number of periods, but let me show you how we get into this. So I'm using that formula. I know my future value is over here, is this value over here, comma 5,1. And I need to solve for the value of the amount that I'm putting away each month. So these monthly payments is my x. I know what my interest rate is. So 1 plus my interest rate is 0,09. Compounded monthly, so I have to divide by 12. And it's for 5 years times 12. Because I divide by 12 here, I have to times by 12. Because each year there's 12 periods. Okay. So this is minus 1, and then I divide by my interest rate. And again, my interest rate is divided by 12 over here. So what I need to be doing now is I need to solve for my x. So if we put this whole thing in our calculator on the right, what we'll get is, so nothing changes on the left, but what we have on the right is, I'm going to put this in my calculator. When we put that value in our calculator, we get this. So what you need to be careful of is don't round. I've shown it as a round number. I've rounded this, but in my calculator, I'm going to keep this in my ans button. Okay. And what I'm going to do is I'm going to say x is equal to 454,745, 5,1 divided by 75. So what you'd see in your calculator, you should see this divided by ANS. Okay, because you're going to work out this, and this is going to be your ANS. So this whole thing. So you're going to be dividing by ANS, but here I'm just going to be showing it as 75,42. And when I do that, I'll be getting 6,029,18 Rand. So if you don't get this answer over here, it's because you've rounded. So make sure you don't round until the end. Good. So what we have over here is similar to, so first we're in section B now. So half of the paper is already done. What we have now is we have a person that's able to pay 14,000 Rand per month, okay? And they're paying off a loan. So the bank offers this person an interest rate of 12% per annum compounded monthly. So we're compounding monthly, we're gonna have to be careful again. We're gonna have to be dividing by 12 and then timesing our n by 12. So it says, what is the maximum loan the person can get from the bank if it needs to be paid back over a period of 20 years? And round down to the nearest 100 Rand. All right, so I'm going to go more detail into this in another video, but for now, you can just memorize that when we're dealing with loans, we're dealing with present value. Okay, we're using the present value formula. So the present value formula, I should have put over here, but let me just find it for us. Where is it? Here it is. So the present value formula is equal to x power 1 minus 1 plus I to the power minus n over I. This is our present value formula. So we know our monthly payments. This is our x. We know our interest rate I, and we know the number of periods, which is not n, but 20 is not our n, but it's related. Okay, so let me not put the n there actually. You'll see what I mean in a moment. So for our x, we just put our 4,500. Then we put our 1 minus 1 plus. Our interest rate is 12% compounded monthly, so we divide by 12. And to the power of 20 years, but there's 12 compounded periods per year. So we have to times 12. Again, we divide by 12 times by 12. Okay, then all of this is divided by our interest rate, which is this. And again, I've said it before, make sure we divide by 12 over there. Okay. When we do that, what we should be getting in our calculator, when you evaluate all of that, we should be getting that the loan amount is 1,316,800. And remember, this number, make sure we round down to the nearest 100. Okay. So you'll get a value. Let me actually put the value in between here. So if you just put it in your calculator, what you'll get as like a raw value is this value over here, comma 5, 4. So this is what you would get, but we have to round down to the nearest 100. So the nearest 100 rounding down is 800. So that's why this is our final answer here at the bottom. This is our final answer. Okay. In part B, I say if the loan above is taken up by the person, what will the outstanding balance be at the end of the 8th year? So immediately after this installment has been made, if they made payments of 14,500 per month. So again, this 8th year is related to our N, and we're trying to work out the outstanding balance. So as I said before, I will go into more detail into this in another video, but for now, what you can do is you can memorize the formula that the outstanding balance is equal to this formula over here. Whoops, it's actually equal to the principal loan amount times N minus the future value of the payments. So you can memorize this formula. I will go into more detail explaining this. So let's work out this first part. So this first part is just a normal compound interest formula. Okay, so where this principal amount is our loan amount. So let me write out our loan amount up here for us. The loan amount, let me just do this. Here's the loan amount. So the loan amount is 1,316,800 Rand. That's our loan amount. So this P is just our loan amount up here. So I'm going to write 1,316,800. 1 plus, and our interest rate before was 0.12 compounded monthly. So I just rewrite that. And for my N, it's 8 years times by 12. Okay, so divide by 12 times by 12. All right, when I evaluate this, I'm going to get 3,422,722,59. All right, so that's my first part over here. So that was part 1. This is my second part. So for part 2, I have to do future value of payments. So future value is given by this formula. 1 plus I to the n minus 1 over I. That's the value for future value of payments. So if I evaluate this, I know my x is, this value over here is my x, 14,500. 1 plus my interest rate is 12% over 12. Our number of periods is 8 times 12 minus 1 all over 0.12 over 12. So just cancel, that should be down here. And when you evaluate that in your calculator, you get 2,318,945,74. All right, so we have part 1 and part 2, but now we need to apply this, and we need to be saying 1 minus 2. So remember, this is the value for 1, and this is the value for 2. So the outstanding balance is equal to, we take 3,422,722,59 minus 2,318,945,74. And when we do that, we'll find that the outstanding balance on the loan is 1,103,776,85 Rand. Okay, remember the Rand. In this question, we need to calculate the value of x if we sum 3n plus 5 from n equals 3 to x. We need to find x, and we know that that sum is equal to 711. So we know that this is an arithmetic sequence, and the reason we know that is because this thing here in the brackets is arithmetic. But what we also need to do is we need to find out the number of terms in this sequence. So the number of terms is equal to our top number, x, minus our bottom number, 3, plus 1. So our number of terms here is just x minus 2. So this wouldn't matter if we started at n equals 1, because in that case, the number of terms would just be x, because you say x minus 1 plus 1. So normally we don't worry too much about this, but in this case, because we're starting n equals 3, we need to take extra care with the number of terms. All right? So in this equation here on the right, n is for the number of terms. So we know the number of terms. It's this thing over here. So we know our n. To find this d, we just look in front of n. So this is d, because it's an arithmetic sequence. And to find a, we know that a is just equal to the first term. So the first term here is when we substitute n equals 3 to that thing inside the brackets. So we get 3 times 3 plus 5. So that's 9 plus 5, which is 14. So now we have a. What we also know is what the sum is equal to. It's what's here on the right. We know the sum is equal to 711. So we have all the information we need. So let's get into solving this problem for x. So we know the sum is 711. N is the number of terms, which is x minus 2 over 2. And then our a is 14. Plus our number of terms is x minus 2. Then we minus 1 from that. And times by d, our constant difference, which is 3. So remember to include this times 3, otherwise you'll be getting a syntax error in your calculator, like before. All right, so what we can do is we can times both sides by 2. So we get 1,222 is equal to x minus 2 in a bracket, careful, is equal to 28 plus, then this will give us x minus 3 in a bracket, times 3. And if we keep working with this on the right, what we'll get is x minus 2. And what we'll get here is we'll get 3x. And then 28 minus 9 is 19, positive 19. Okay, so what we need to do is we need to FOIL this out on the right. And when we do that, we're going to get 3x squared plus 19x minus 6x minus 38. And we're going to take this to the other side. So we're left with 0. We go to 3x squared plus 13x minus 1460. So now we can use our calculator again, like we've discussed before, in when we press mode 5 for equation. And if we do that, put in our calculator, we will get the following answers. We'll get x is equal to 20, or x is equal to minus 73 over 3. We know that this is not valid because this number here at the top has to be a positive integer. Okay, so it has to be a natural number. So we know that this is not valid. Excuse me. So this is the only valid answer for x. X is equal to 20. In the next question, we're given this diagram, and we're given that the ball bounces indefinitely along the path modeled below. The ball starts at A, where it's catapulted into the air before bouncing at the first time at B. So it's shot up here and then bounces for the first time at B. So the horizontal distance, BC, is equal to 3 over 4 AB, and CD is equal to 3 over 4 BC. So here we can see that we have a geometric series, where this is our common ratio. And we also know that each bounce is modeled by this equation, by this formula, this equation for a parabola. And we can see that these are parabolas. So it says if the ball continued to bounce, it would eventually converge with the horizontal 16 meters from A. So it would converge with the horizontal 16 meters from A. So if this ball just kept going and bouncing, eventually it will converge somewhere at 16. Okay. So now that we have that, let me put this back. So we know that it'll converge at 16 meters. So this is just the information for the problem. The first question is determine the length of AB. So they want this length over here. So let's take a look at what we know. We know our common ratio is R. What we also know is that this thing will converge with the horizontal at 16 meters. That's if it goes indefinitely. So we know that this 16 is the sum of the terms to infinity. So this is meant to be an S to infinity. We know that we have this. Okay, so we can actually use the equation for the sum of terms to infinity for a geometric series, which is just this. It's just this equation over here. And we know that R has to be between -1 and 1. And that's fine because our R is between that, because we know our common ratio, is equal to 3 over 4. And we also know our sum to infinity. So we know that AB is this length over here, which is our first term in our geometric series. So that's why we have our R, we have our sum to infinity, we just need to solve for A, which is the length of AB, the first term in our series. So we know that sum to infinity is 16, we don't know A, and we know that our R is 3 over 4. So we know that 16 is equal to A over 1 over 4. So we know that A is equal to, and we take this to the other side, so 16 times 1 over 4, which is equal to 4. And the distance of the ball is given in meters. So it's given in meters. So our answer, oops, wrong way, here needs to be in meters. Okay, so we can say therefore AB is equal to 4 meters. Okay, you don't actually have to put the meters there. Not as important as putting it over here. Okay, so we know AB is 4 meters. So we know that this has to be 4. Good. In the next question, they ask for the maximum height reached by the ball between points C and B. So they want the maximum height. So they want this over here. They want this height, this vertical height. So we know B is 4. And we know that this whole parabola, any given parabola, so B to C or C to D, is given by this equation. This was given in the information. I'll show you in a second. It's given over here. They gave us this. Okay. So we know that information. So we determine the length of AB, and we can also determine the length of BC, because we know also from the information sheet that BC is equal to 3 over 4 AB. And we know what AB is. We just worked it out. It's 4. So that means that BC is equal to 3 meters. So that means that C has to be 7, because from 4 we move 3 units and we get to 7. And what we know is this maximum height will be halfway between these two x-intercepts. There will be halfway between. And halfway between these two will be 5, 5. Because if the distance is 3, half of that is 1, 5. So if you move 1, 5 from 4, you end up at 5, 5. So now what we know is we actually know P. Because P is the x value of the turning point, because the maximum height is reached at the turning point over here. So what we know now is y is equal to minus 1 over 2 x minus 5, 5 squared plus q. So that's what we know over there. So we have this, and we need to solve for q. So to solve for q, we can sub in an x and a y, because that'll give us our q. We just need to sub a point. So we actually have two known points. We know this point and we know this point. So this is the point x4, y0. So we can just substitute that in. So that should be a negative. And that's 4 minus 5, 5 squared plus q. When we put this in our calculator, we get q is equal to 9 over 8 meters. So remember, this form over here is given in the form of the x value of the turning point and the y value of the turning point. So over here, this would be PQ. So because we know Q is 9, 8, we know that the maximum height reached between points B and C is this value over here, 9 over 8 meters. Good. Over here, we're given Wx, function Wx. We're given the function t of x, which are both straight lines, and they're both axes of symmetry for the given graph h. This given graph h over here, which is a hyperbola. We're given the point E, it's over here, and it lies on h. And ABCD is a rectangle with AD on the x-axis. So that's our information for the question. Question 1 asks us, if the hyperbola formula is given as a divided by x minus p plus q, find the values of a, p, and q. All right, so what I'm going to do is I'm going to write the equation of w is y is equal to negative x plus 6. And the, oops, wrong way. The equation of t is x minus 4, sorry, over here. And y is equal to x minus 4. So we should remember from our theory that this point of intersection between the axes of symmetry is important, because the axes of symmetry intersect at the point where the horizontal asymptote, so our horizontal asymptote, and our vertical asymptote intersect as well. So this point of intersection is important with our axes of symmetry, because that's also the point where our vertical asymptote and our horizontal asymptote intersect. So what we can do to find the x-coordinate, we can just set the two functions equal to each other to find the point of intersection. So when we do that, we get minus 2x on this side, it's minus 10. So x is equal to 5. So we know that this point here is 5. So we also know that, so therefore p is equal to 5. Because remember, p is the x value. So P is the x value of our vertical asymptote. So P tells us our vertical asymptote. Then to find Q, we just need to find the y value of this point. So we can just substitute 5 into either straight line equation, this one or this one. So what I'm going to do is I'm going to say y is equal to x minus 4. And we're substituting our x as 5. So that's 5 minus 4, which is 1. So therefore Q is equal to 1. And now for A, I'm just going to rewrite what we have so far for hx. We have this so far, plus 1. And we need to solve for A. So what we can do is we can just substitute a point on h. And we're given a point on h. We're given this point E, which is 9, 2. So if we do that, we can solve for A, because we get rid of our y unknown and our x unknown. So what I'm going to do is I'm going to put my y in here, and I'm going to put my x in over here. And if I simplify this a bit, that's over 4 plus 1. So I'm going to get 1 is equal to a over 4. So therefore A is equal to 4. So there we go. I've got my values of A, P, and Q. Now we have to determine the area of rectangle ABCD. So A lies on the x-axis, and so does D. But what is special about point A? Point A is the point of intersection of the hyperbola with the x-axis. So our formula for the hyperbola, we just worked it out in the previous question, is this. So I'm going to use this to find my x-axis, sorry, my x-intercept. My x-intercept is when y is equal to 0. So I'm just solving for this. So I get minus 1 is equal to 4 over x minus 5. So I get minus x minus 5 is equal to 4. So minus x plus 5 is equal to 4. So what do I get? I get minus x is equal to minus 1. So x is equal to 1. So I know the coordinates of A is 1, 0. So therefore A is 1, 0. Okay. So I have the coordinates of A. And to find the coordinates of C, I also need the coordinates of C. So to find the coordinates of C, I'll notice that it's the intercept between this line T and the hyperbola over here. And if you remember, T is given by y is equal to x minus 4. So we need to solve for that point of intersection. So 4 over x minus 5 plus 1 is equal to x minus 4. So 4 is equal to x minus 5. Whoops, I was meant to have this down here. So when I do that, I get 4 is equal to x minus 5 squared. So 4 is equal to x squared minus 10x plus 25. So I'm going to just continue over here. X squared minus 10x plus 21 is equal to 0. So I have x minus 7, x minus 3 is equal to 0. So x is equal to 7, or x is equal to 3. But I know that D has to be the greater number because there's 2 points of intersection with T and H. So it's either here at C or down here. So I know the one down here has to be the smaller x. So this would be 3. And I know this one has to be the bigger x. So I know that this has to be 7, 0. So now to work out this area of the rectangle, I need this length and this breadth or height. So that's good. I've got this length. It's 6. I know this length is 6 units. And I just need to find this height now. But the thing is, I know the x coordinate of C. I just got it over here. I know it's 7. So I can plug the 7 into this equation, or my hyperbola, to find the y value of C. So that's exactly what I'm going to do. I'm going to say y is equal to 7 minus 4, which will give me 3. So I know the point C is 7, 3. So therefore, the area of rectangle ABCD is equal to my length times by my height. Remember now this is 7, 3. So I know this height is 3 units. So 6 times 3, which is 18 units square. Now what we need to do is we need to sketch g of x on the set of axes below. So g of x is given by log base 2 of x if x is less than or equal to 4. So we can only plot from here and to the left because of our restriction. So to plot a graph like this, so firstly we should remember what the general log x, general logarithmic graph looks. So you should remember from your theory that it looks something like, not like that. It looks something like this. Okay, so again, it's not perfect. Let me try one more time. It's going to look something like this. That's a general log graph. Okay, so that's the general shape, which is important to know. But we also need to know the x and y intercepts. So firstly, you would notice from the shape that I just drew, we never cut the y-axis. So there will be no y-intercept, and you'll see that in a moment. So to work out the x-intercept, we said y is equal to 0. So we have log 2 of x is equal to 0. And the inverse operation of log 2 is we set everything to the base 2. So that's what we have there. And log 2 base 2 will cancel and we get x. So we have x is equal to 1. So we know that here is our x-intercept. All right. And to solve our y-intercept, we set x is equal to 0. So log 2 of 0. But this gives us a math error. This is impossible. Okay, if you put this in the calculator, you'll get a math error. So this is impossible. So we can never have a y-intercept. And the reason for that is because we actually have an asymptote here. We have an asymptote over here. So as I showed before, the base form of a log graph has an asymptote over here. And that's what we just showed over here. But we know we have to plot from the left of 4. So we need to actually find out what the value of our function is at 4. So what we do is we know the x value is 4. So what we need to do is we need to actually plug in, we need to find the y value when our x is 4. Okay. So when we do that and we put it in our calculator, you'll find y is 2. So over here. So our function will look something like this. Okay, this will be our function, and this will go to infinity. Okay, and we should label this point. This is 0.42. So that's how we sketch that graph. What we have to do now is on the same set of axes, we have to sketch this graph. So g to the -1 of x. So this is the inverse of g. So g of x is given over here, is equal to log 2 of x. But inverse just means we swap x and y. So now what we do is we write x is equal to log 2 of y. Okay? But we know that the inverse operation of log base 2 is putting everything to the base 2. And we're just left with y on the right. So this is our inverse function. Y is equal to 2x. But what we need to be careful of here is before we had this restriction on x, x is less than or equal to 4. But in this case, our restriction, because we swap x and y, it's no longer x is less than or equal to 4. It's now y is less than or equal to 4. That's our restriction here. So to find the x value, when our y is 4, what we do is we just solve for 4 is equal to 2 to the x, because we're just putting a 4 here by our y. So careful, that's not y to the power of 4. I'm just saying instead of y, we put a 4. Okay. So I'll see that my x value is 2. So I'll see x value is 2. So I'll know I'll have the point 2, 4 over here. So here's 2, 4. So I'll know I'll have this point. And we should remember that the base form of an exponential graph looks something like this. So we know we're going to have something like this. But let's just confirm by finding our x and y intercepts. So there is no x-intercept for an exponential graph. You can remember that from theory, but you can also check that if we try to find the x-intercept, we set y is equal to 0. So we get this, and we'll see that this is never possible. So there's no x-intercept. But if we want to find the y-intercept, we set x is equal to 0, and that's just 1. So we know we intercept with the y-axis over there. One thing that I just noticed now, sorry about this, we should have also labeled this point, the x-intercept. All right. But now we have everything we need to plot the inverse of so we have everything we need to plot for this question, g to the power minus 1, the inverse. So we know it will look something like this. Okay, and this will go on to infinity. And we know we have a horizontal asymptote over here. Okay. All right. So let's label this point. This is 2, 4. And you can see, notice how these are swapped. These are swapped between these two. And it's because they're inverses of each other. Okay. So you'll see how this was the x and y, and this is also x and y, but now they're swapped. The x and y's have swapped. And that's because they're inverses of each other. Okay. And let's label this point 0, 1. One other thing I forgot to do is we have to label these asymptotes. So here, this vertical asymptote for our log graph is x equals to 0. And for our exponential, we have y is equal to 0 for our asymptotes. So remember to show the asymptotes and label them as well. For question 3, they ask for the domain of the inverse of g to the negative 1. So the domain of this function over here. So I know before there was something funky going on with this x, and we swapped it with the y, but here we don't have to do anything funky. It's just the domain of this function. So domain has to do with the x values. So what possible x values do we have for this function, this g function? And you can see we can go anywhere from negative infinity all the way up to here, 2. We can go all the way up to 2. So to write that, we say x is an element. So, sorry, x is an element of, let me try again. X is an element of, and we exclude negative infinity, but we include 1. And by 1, I mean we include 2, because we can go all the way up to 2. And we include 2, because the function exists here at 2. Okay. For this next question, they ask for the values of this monstrosity when this is less than 0, less than or equal to 0. So less than or equal to 0 means negative. So when this thing is negative. But first, let's look at this. This is one thing we haven't evaluated yet, g prime of x. So g prime of x just is the gradient of x. So let's look at that. Here is g. And when I said the gradient of x, it's the gradient of g, sorry. So over here, g prime of x is a gradient of g. So the gradient of g just means if we draw a tangent. So for example, say we're at this point over here, and I draw a tangent, it will look something like this. Let me actually use another color. That'll help. So the tangent will be something, that's not a tangent. Tangent will look something like this. We touch in one point over here. And you'll see no matter what tangent we draw, if it's there or even here, it'll always be positive. The gradients of these are always positive. So we know the gradient for g prime of x, sorry, we know that this thing is always positive. So we can just say g prime of x is actually just always positive. So we don't even have to include this in our evaluation. So essentially what we're just seeing is when this is less than or equal to 0. That's all we need to find. And when this is negative, we know we either need to have a positive divided by a negative, or we can have a negative divided by a positive. So they need to be on opposite sides of the x-axis. So one needs to be above the x-axis, one needs to be below. Or in other words, one needs to be a positive y value and one needs to be a negative y value. But what's also important, g of x cannot be 0. So we know that g of x can't be 0 because otherwise this would be undefined. All right, so let's have a look. Where is the one above? Here, when is the one y positive and when is the one y negative? So here, over here, okay, let me use another color. So anything over here, this is our g. G is negative. Anything over here, g is negative. It's below the x-axis. Here's the x-axis, and you see how we're below, okay? But our other function, this is g, the inverse, this one's always above the x-axis. All right, but g only exists from 0 because this is x is equal to 0. So g only exists from this point to the right. All right, and we see that g, the inverse of g to the power negative 1, is above from this point over here, which is x is equal to 0. It's above up until this point, right? This point, this y value is 0. So g's y value is 0 over here. So g to the power negative 1 is above the y-axis, and this one is below up until this point where they both start to move above. Do you see how here's our x-axis over here, and you see how g, I'm showing it here in blue, g starts to move above, and g to the power negative 1 is also above here. So we can only consider this to the left because they're asking whether one's positive and the one's negative. I know there's a lot of scribbles over there, but I hope that is making sense. All right. So we know we have to be between 0 and 1, okay? Because this is 1 over here, 1. And this is our x value 1 over here. So we need to be careful. Can we include x is 0? And the reason is no, because we have an asymptote for g there. G can never go until x is 0. The x for g can never be 0. But can we include this 1? Can x be 1? And again, the answer is no, but for a different reason. The reason is because g of 1 is 0. So the bottom graph over here, this is 0 when x is equal to 1, and that's not good. So we can't include x as 1. So what you do is you write x as an element of, we don't include 0, and we don't include 1. All right. Another way to write this is you could just say x is between 0 and 1, not including. All right. In this next question, we're moving over to probability. We're given those numbers there, 1, 3, 6, 8, and 9, and we have to create 5-digit numbers. They say how many unique 5-digit numbers can be created if repetition is not allowed. So for these, we have to do this underscore thing. So we are creating 5-digit numbers, so we put these 5 placeholders. Okay, so these straight lines over here are placeholders. So we're not allowed repetition. So if we use a 9, we can't use a 9 again. So if there's a 9 first, so say for example we put a 9 first, that means now we have 4 options left over. Okay, so initially we had 5 options, but we put a 9, so now we have 4 options. So it's similar to what we do over here. In the first spot, there's 5 options we can start with. But if we put that option over there, that means now we're left with 1 less option. And again, then we're left with 1 less, and 1 less, and 1 less. Okay, so when you arrange them like this, because repetition is not allowed, if you use one number over here, that means now over here you're left with 4 other possible numbers you can put in. And then if you've used 2, you only have 3 left for the next position. Okay, so this is what we do over here. And what we do to work out how many unique 5-digit numbers are, we multiply all of this. So we say 5 times 4 times 3 times 2 times 1. So this is the same as saying 5 factorial. You could also just put this thing on the left in your calculator. But if you do 5 factorial, we get 120. So there's 120 unique 5-digit numbers that can be created. So now they say, what is the probability? Important working with probability now, that a unique 5-digit number starts with an 8 and ends with a 3. So we have to start with an 8 and end with a 3. And repetition is not allowed. So again, we do our placeholder thing. And we have to start with an 8. So how many options do we have for our first place? We only have one option. It has to be an 8. And similarly, at the end, how many options do we have to end with? Only one. We can only end with a 3. But now we've used 2 options out of a possible 5. So for this slot, we can put 3 numbers in there. And if we've used now 3, we're left with 2. Okay, and very similar, we just multiply these. And when you multiply that, you'll get 6. So there's 6 possible numbers that start with an 8 and ends with a 3. But they ask for the probability. So we know there's 6 that meet this criteria, but how many are there in total? There's 6 options here, but how many total options are there? And these are our total options, 120. So the probability is not, I'm not going to put a bracket there, is 6 over 120, which is equal to 1 over 20. That's our probability. Now, we have to create even numbers that are greater than 65,000. And repetition is not allowed again. So I've put our options here on the top right. These are numbers we're working with. And the numbers have to be even and greater than 65,000. So let's just talk about even numbers. Even numbers end with 0, 2, 4, 6, and 8. So we have to end with one of those. And to be greater than 65,000, that's a bit self-explanatory. It just needs to be bigger than 65,000. So let's look at some options. Let's say, so firstly, we can't start with a 1 or 3, because that immediately won't be bigger than 65,000. But let's say we start with 9, because any number we start with 9 will be bigger than 65,000. So let's say we start with 9, and we can end with a 6 or 8, because both of those will give us an even number. So if we do our placeholders, we start with a 9, there's one option we can start with. But there are 2 options we can end with, a 6 or an 8. And that means here we're left with 3 options, here 2, and here 1. So we just multiply all of these together, and we get 12. So there's 12 options in this case. But we're not done, because what we can also do is we can start with 8. So if we start with an 8, we have to end in a 6 to make it even. So if we do our placeholders, we start with an 8, one option, and we end with a 6, one option. So now we're left with 3 options here, 2 options there, and 1 option there. So that gives us 6 possible options over here. If we start with a 6 and start with an 8, end with a 6. Now we need to be a bit careful. Let's say we start with 6. We have to end with an 8. All right. But not all numbers that start with a 6 will be bigger than 65,000. For example, if we have a 6 and then a 3, that's immediately not bigger than 65,000. So we need to consider that. But let's see how it looks when we do placeholders. So we have to end with an 8. We only have one option. And we have to start with a 6. We only have one option there as well. So if we look here in the top right, the only number that will be bigger than 65,000 is if our next number is 9 after the 6. So we only have one option here. And that means we have 2 options over here, because we can either put a 1 or a 3 here. So there's 2 options there. And then because we've placed that 1 or 3, we only have one more option here. So over here, if we times all of these together, like we've been doing, so again, sorry, I should have put this here, times. This will give us 2. So we need to add all of these together to find the total number of, we have to add these all together to find the total that meets our criteria here at the top. So if we add all of these together, we'll get 20. So there are 20 total unique even numbers bigger than 65,000. Now we're working with kettles. So a factory produces kettles, and it's known that the probability of producing a defective kettle is 1 over 65. How many kettles would you expect to be defective? So be defective if 90,500 kettles are produced by the factory. So if 1 in 65 are expected to be defective, what we can do is we just say 90,500 times by 1 over 65. This will give us the number of expected kettles that are defective. So if we put this in our calculator, we get 300 kettles. All right. Then in the next question, it's a bit more complicated. If you produced 150 kettles, what is the probability that none of these kettles would be defective? Round off to 4 decimal places. So careful, it is not the same as what we did in number 1. And you can tell it's not because it's worth 2 marks. All right, and they wouldn't repeat the same thing twice. So we need to be a bit careful. Let's think about if we have a coin. If we have a coin and we flip it twice. So the first, it's a 50-50 chance that it's a head or tail. But there's a possibility we get 2 heads in a row, or possibly we get 2 tails in a row. All right. And if we expand that even further, say you flip the coin 4 times, there's a possibility that it's 4 heads in a row. Okay. So it is possible that if we make 150 kettles, all of them there might be no defects. There might be no kettles that are defective. But to work out the probability, if we're working with heads and tails, you would work with the tree diagram, right? Remember these? So if we look at the case where I want 2 heads, to work out the probability of that, so 1 over 2, 1 over 2. To work out the probability of 2 heads, what I do is I take these probabilities and I times them. The probability of head and a head is 1 over 2 times 1 over 2. And if I wanted a head and again, now I just say 1 over 2 times 1 over 2 times 1 over 2. All right. So the probability of heads, right? Head times head times head times head, all the way up to this for n times, right? So say, for example, I want the probability of n heads, okay? So this is just some variable. Let me call it x. So the probability that I get heads x times in a row, for example, 10. To work that out, I would just say the probability is 1 over 2 to the power of x. So I hope that makes sense. So you can think of this with the kettles. The probability is just the probability of not defective, which is the probability of defective is this, 1 over 65. So that means if we draw a tree diagram like this, we're going to have defective and not defective. So the probability of defective is 1 over 65. So the probability of not defective has to be 64 over 65. All right. So now you can imagine with this tree diagram, you're going to have defective, not defective, def. And this again is 1 over 65, 64 over 65. And you see you would have to go down this tree 150 times. Or what we could do is you could just say 64 over 65 times each other 150 times, which will give us to 4 decimal places 0,0977. Here it's given that the probability of A is x, the probability of B is 0,6 plus x, and the probability of A and B is 36 minus x. If the events of A and B are independent, find the value of x. So we need to use a theory that says the probability of A and B is equal to the probability of A times the probability of B if they are independent. So if A and B is independent, then this is true. So we know that the probability of A and B is just this. The probability of A is this. And the probability of B is given at the top, like this. All right, so I just need to expand this out on the right. So I get this on the left, and on the right I get, this should be 0,6x plus x squared. And if I simplify this, I get 0,36 is equal to x squared plus 1,6x. So what I do is I get x squared plus 1,6x minus 0,36 is equal to 0. And here I'm just going to be using my calculator. I can put it in that equation mode like before. Or you could factor this, but when you do that, you get x is equal to 0,2, or x is equal to, if I put this in the calculator, 1,6. So you get x is equal to 0,2, or x is equal to minus 9/5. Okay, but this on the right is not valid because we have this. We have the probability of A is equal to x, and the probability has to be greater than 0 because probability is between 0 and 1. So probability is between this. So it can't be negative. So this is not valid. So x has to be 0,2. Here we're given two drones and their flight paths. So the drone here at C is given this flight path modeled by this parabola that's given over here. And the drone at D has a flight path modeled by g of x is mx plus 5, this straight line equation over here. So CD is 7 meters and AB is 2 meters. So this over here is given by G, the straight line over here. And this 5 gives us the y-intercept. So we know that B is 5. So we know that this part over here is 3 units. So we know that A is a 0.03, just like B is a 0.05. Okay. So we can use this information to find Q. So this is just looking at the information. Let's see what they ask in question A. They say that the point E is directly above C, and they want us to calculate the length of EC. Show all your working. So we're going to have to take the top minus the bottom, because that's how we determine vertical lengths. So we're given these two equations, and again, I'm going to write what we found before. We know that A is 0,3, and we know that B is 0,5. And we know that again because of this. This is the y-intercept of this graph G. All right. So we have that, and we can use that to find the equation of Q. And the reason we need the equation of the equation of F, and we're going to find Q to find the equation of F. The reason we need that is because we need this x value at C. So we can find this B, this is the E, sorry. We need to find the y value of this E and the y value of this x, which we know is 0, but we need to use this x value to find this y value up here. So we're going to have to find Q. We know that Q has to be 3 because this Q will give us this y-intercept over here. So we know Q is equal to 3. And we can use this equation we have now where f of x is equal to minus x squared plus 2x plus 3. We can use that to find for C, because C is the x-intercept. So we said y is equal to 0. And we get this. And I can just times by a negative, so I'll get this. And I can factorize this, like so. And I get x is equal to 3, or x is equal to minus 1. So C has to be 3, 0, because if you draw this parabola down here, it will intercept here at minus 1. But we know that C has to be the positive x-intercept. Okay. So we know this x value. We need to find the y value of E. But the problem with that is we don't know this m. We don't know m, so we can't find the y value because there's an unknown over there. But what we can find out is we know what the value of d is. Because if this is 3 and this is 7, d has to be at the point 10, 0. So we know this coordinate. So we can substitute this coordinate in to find the gradient. So what we're going to do is we get 0 is equal to m times 10 plus 5. So we get minus 5 is equal to 10m. That means that m is equal to minus a half. So now we have the equation of g. We can use that equation to find this y value at e, because we know what the x is. We know the x is 3 at this point. So let me write that x is equal to 3. And that's true for e. So what we do is we say y is equal to our gradient, our x value at e, plus 5. When we do that, we find that this is 7 over 2. So we know that e is the point 3, 7 over 2. So we know that distance EC then is just distance 7 over 2, which is just 3.5 meters. Because they've given us units in meters, so make sure we answer with the units meters. Now, a friend of ours says the vertical distance between flight path DB, so the straight line path, and the parabolic flight path AC will never be less than 40 centimeters. Is your friend's statement correct? So he's saying this distance here will never be less than 40 centimeters, this vertical distance. Obviously, there's no vertical distance here because the one drone's flight path doesn't exist. So it's just up until here. So he says this flight path, the vertical distance, will never be less than 40 centimeters. So what we need to do is, he's saying that it will never be less than 40 centimeters. So he's saying the minimum is 40 centimeters. It will never be less than that. So in terms of working with minimums, we have to work out, or we have to use optimization. So first we need an equation that we're going to optimize. And we need to find out the vertical distance. So I'm going to call the vertical distance function h. Okay, so this is for our vertical distance. I'm just calling it function h. And to work out vertical distance, we take the top function minus the bottom function. So our top function, which we've worked out before, is this. And we need to minus our bottom function, which was the parabola, which was given by this equation. So this is our vertical distance formula. So we need this first, so we can minimize this equation to find the minimum vertical distance. So when we do that, we get, that should be a plus. We collect like terms. And what do we get here? We're going to get minus, what does this give us? Minus 5 over 2. This gives us minus 5 over 2x plus 2. So this is our equation for the vertical distance. So what we need to do now is we need to minimize this. So what we have to do is we have to take the first derivative of this equation. So this is what we do when we get the first derivative. So to minimize is when we set the gradient equals to 0. So that's why we worked out the first derivative, to get the gradient. So we need to find where this is equal to 0. So we take this 5 over 2 to the other side, and we're going to get x is equal to 5 over 4. So this is the x value. We need to be careful now. This is the x value where the vertical distance is a minimum. So it's only the x value. We need to find the actual minimum vertical distance, because our equation for vertical distance is given by hx. So we know that at this point over here, we will have a minimum vertical distance. but we need to put this minimum vertical distance, so we need to put this coordinate, or this x part, into our h of x formula to find the vertical distance, because this is just the x coordinate, and this will give us, if we plug it in here, this will give us our vertical distance. So this says this thing just says there's a minimum here. Minimum here. So that's just saying, oh, we have a minimum here, okay? But it doesn't tell us what the minimum is. To find what the minimum is, we have to put it in here, and this will say what the minimum is, so minimum value. So that'll give us our minimum value. In this case is vertical distance. So I hope I saved myself with the wording there. It started a bit shaky. All right. So our minimum vertical distance will then just be, I'll call it y is equal to, you say 5 over 4 squared minus 5 over 2, 5 over 4 plus 2. And if I put that in my calculator, I will get this value 0.4375. And careful, all of our values are in meters, but they were talking about centimeters. So this is meters, but this is equal to 43,75 centimeters. So our minimum distance is this, 43,75 centimeters. And it's true that the minimum distance they'll never be closer than 43,75 centimeters. So your friend statement is correct. And we need to say that. So you say, therefore, our friend statement is correct. Because this is our minimum distance, and it will never be less than 40. Now we get to the final question. This final question is quite an interesting one, but let's tackle it as best as we can. So below is a sketch of f prime of x. So a and b lie on f prime of x. So here's a and here's b, and c is the turning point, and c is on the x-axis. So let's just take a quick notice at what we see here. So what do you notice between the y values between a and b? The y values are the same. So that means we have to be symmetrical about this point over here. So we're symmetrical about this point. Okay? And we know the distance, the x distance is 6 units. From -1 to 5, we have to go 6 units. So the distance, let me just write here, distance is equal to 6 units. Okay? So if we go halfway between, we have to move 3 units this way, 3 units. Or we can just move 3 units this way, 3 units. So we'll realize that this x value has to be 3 units to the left of 5. So this has to be the point to 0. Because if we move 3 to the right from -1, we end at 2. If we move 3 to the left from 5, we end up at 2. All right. So this is just using the information they've given us. Now they say f of 0. So careful, there's no prime here. They say f of 0 is equal to -14, and f of 2 is equal to 2. Calculate the x-intercept of f. So the x-intercept of f. So this thing that they've given us over here is f prime of x. So f prime. They're asking about f of x, which is interesting. All right. So if this graph of f prime of x is a parabola, right? So the equation for this will be x squared. It will be something like ax squared plus bx plus c, right? It'll be something like that. So if we move backwards and we say, okay, this was actually our derivative, we know that the function above, so not f prime of x, fx had to be some cubic function, has to be x to the power of 3. All right? So we know that f prime of x is equal to 0 at x is equal to 2. So this means that f has a turning point, TP, at x is equal to 2. And here, this is x. So we know this function over here, we know what its turning point x and y is, because this is the x and this is the y. So we know the turning point values for f. So what we can do is we can use this form that I'm not sure how well it's taught or if it's taught at all, but we can use this form over here. We can use that for a cubic. We can use a turning point form. So you'll see this form is very similar. It's actually the exact same as a turning point form for a parabola, but instead of to the power of 2, we have to the power of 3 because it's a cubic. And we know we're working with a cubic because of what I've shown over here, that this is the derivative and it's a parabola. So if we move backwards, we have to start with x to the power of 3. Okay, so we can fill in details we know over here. We know our a, sorry, we don't know our a. We know the x value of our turning point, and we know the y value of our turning point because it was given. And we know we had a turning point at x is equal to 2 because f prime of x is equal to 0 at x equals to 2. So we have this. But to find the x-intercept, we need to find a, so we can find the x-intercept. But to find a, we just need to substitute a point. And luckily enough, they've given us another point. We know that our y value is equal to negative 14 when our x value is 0. So we just solve for this. So minus 14 is equal to minus 8a plus 2. So what that gives us is a is equal to 2. So our final form of our function, our cubic function, is 2x minus 2 cubed plus 2. And now to find the x-intercept, we set y is equal to 0. So 0 is equal to 2, x minus 2, 3 plus 2. So now what we're going to do is we're going to get minus 2 is equal to 2x x minus 2 cubed. And we divide both sides by 2, and we're going to get minus 1 is equal to x minus 2 cubed. And we can just take the cube root of both sides. So that means that minus 1 is equal to x minus 2. We've just taken the cube root of both sides, the cube root of both sides. Let me show that. So now we have this. So we know that x is equal to 1. This would be the x-intercept. And that's our final answer. So this one was a bit tough. There are other ways of doing this, and I might go into them in another video or two, but I think this explanation will do for now. So that concludes our final question, and that concludes our paper for 150 marks. So I hope that was helpful. If you guys have any other papers you would like me to do for maths or physical science, feel free to let me know. And if I've made any mistakes, please let me know. If you have any suggestions, also let me know. Thanks guys, all the best for the upcoming exams.